Okay, so when we're looking at symmetry, we've got these two things. One is line symmetry, and that one is related to reflection. But it's not reflecting anything. What it's saying is, are there mirror lines in our shape? So we only have the one shape. So let's just deal with good old basic Mr. Square. So I'm saying this is a square. You'll be able to make your square look square. But I'm saying this is a square. Where can I put a mirror line or a mirror on this shape such that it doesn't change? Emma? In the middle. That's an interesting description mathematically. Want to go a little bit further? A vertical line. All right, so we're going to have one here. If I reflect this, it's going to end up looking exactly the same. Is there another one? Lexi?
Diagonally.
Diagonally, okay. All right, so this one we're going to call M2. Is there another one? Ollie?
Horizontally.
I love these words. Horizontally. M3. No real prizes for what the last one is, but what is it? Esther?
Diagonally the other way.
Diagonally the other way. Let's go with that. Right, so the worst mistake when finding out what the order of line symmetry is that we count around and we go 1, 2, 3, 4, 5, 6, 7, 8. Of course, what that actually is we've counted the lines twice. So by writing M1, M2, M3 or 4 on it, I know there are 4 mirror lines. So 4 mirror lines equates to an order of line symmetry and equals 4. So 4 mirror lines implies that the order of line symmetry equals 4. All right, the next one, there's lots of names for it. One is point symmetry. That's the one we're going to use today. But we can also call it rotational symmetry. We can call it all sorts of other things. So you need to be aware that things in maths can be called different names and are actually just the same thing. So going back to Mr. Square again, the difference between point symmetry and rotational symmetry is we're not rotating it. What we're saying is, with the square, if I picked it up and turned it around, on my travels and turning it around 360 degrees, so in other words, making this point here, come back to itself, how many times will it look exactly like it does on the board? 4. So if I turn it, I can turn it this far, that's 1. I can turn it around to here, that's 2. I can turn it around to here, that's 3. And the last one makes 4. So how many times I'm turning it around? Yes, Ollie?
How do you define the center of rotation?
Okay, that's why it's different from rotation. All right, we are not doing a rotation on this. We are finding out what this shape has as point symmetry, which is different from rotation. It's just that it's rotation we are using. So we're rotating one shape not to get another shape. I could rotate it from out here. It would still look the same. It would be in a different place, but it would look the same on the way around. So through 360 degrees, this one was how many mirror lines? This one is through a full turn, I'm going to say, instead of 360 degrees, but through a full turn, how many times does it look the same? I mean, it'll always look like a square, but we want it to look like a square that's sitting on its bottom, not sitting on its side, on a point or whatever. Lexi.
So point symmetry is just essentially how many points are on the object.
Not necessarily, because it may not have points.
But how would you measure it?
Okay, so let's have a look at one that says that. Here is a shape. Let's say I've drawn an absolutely perfect looking thing, right? How many times on turning it around will this look like that? Esther? Right, so if I put a point on it, let's just say it's this one, I've got once and back to the top. All right, it didn't look like it when it was halfway round because it was long and skinny. I want it to look exactly like that. Emma?
Also, if it's a right angle triangle, for example, it doesn't, and it's not equilateral, it won't look the same at all 3 points.
Yep, so what will be its order of symmetry? How many times on the rotation will look like itself? Once. Everything always has an order of rotation of 1. Okay? Its order of rotation means how many times on the whole thing. So if it doesn't do it at all, for example, that right angle triangle, so let's just put a little one here. Right? The only one on its trip around that it'll look like this is when this gets all the way back to here. Okay, so it is 1. This one is 1, this one is 2. So, the order of rotational symmetry, or point symmetry, is equal to, for this one, and our EG is 4. Okay, so for our square, we've got 4 for the line symmetry and 4 for the rotational symmetry. What do you think the total order is going to be? Total. What does total mean, guys?
How much?
Add it up, right? So this is 4, that's 4, the total is?
4, 8.
Yeah, okay. So our total order of symmetry, yeah, maybe, is equal to the order of line symmetry plus the order of rotational symmetry, right? This one is the ORS. This one is the OLS. So it equals 8 for our square. All right, we just add them up. But this one is the total order of symmetry, or the TOS. Right, any more questions? All right.